Welcome to this Maths Made Easy video on simultaneous equations. And to start with, we're going to take a look at the first method when solving simultaneous equations, which is elimination. So elimination is typically used when working with linear equations. So in this case, as we've got 3x plus 7y minus 44 equals 0, and we have 2x plus 3y equals 21, these are both linear equations, so we would use elimination here. The first thing we need to do is just be slightly careful. Notice our first equation here isn't quite in the correct form for us to use elimination. So to alleviate that issue, we just need to add 44 to both sides. So therefore 3x plus 7y is equal to 44. Okay. Now we just rewrite our second equation then. This gives us 2x plus 3y is equal to 21. Now here, when using elimination, we need to match the coefficients of either the x here or the y. It doesn't matter which variables you pick. In this case, I'm going to pick the x because it makes the numeracy a little bit simpler here. Okay, so in that case, if we times this top equation by 2 and this bottom equation by 3 here. Okay, so we times the bottom one by 3 and the top one by 2. In that case, what we obtain then is 6x plus 14y is equal to 88. So make sure you times each term here across by 2. Repeating this now with this bottom equation, timesing each thing by 3 here. So that gives us 6x again. We get 3y times 3, which gives us plus 9y. And finally, 21 times 3 gives us 63 there. Okay. Now here, we need to think about whether we're going to add these two equations together or subtract. And the way to think about that is we need to get rid of the x's here because we've matched the x's, or the coefficients of the x's. That's the variable we're eliminating. Well, in that case, if we've got a positive 6x here, we've got a positive 6x here, we would simply subtract these. However, if you're struggling to remember on which way you add or subtract, you could just remember das here. Okay? And all this stands for here is if the signs are different, you would add. And if the sign is the same, you subtract. Okay, so because in this case they are both positive 6, we're going to subtract. So writing this as subtraction then, and performing the subtraction, well 6x minus 6x will just simply give us 0x or 0. 14y minus 9y will simply give us 5y here. And finally 88 minus 63 will give us 25. So what we've obtained now is a linear equation in terms of y. We've obtained 5y equals 25. So solving for y here gives us y equals 25 over 5, giving us y equals 5. Now we just have to be slightly careful. We do also need our x solution here. These are simultaneous equations. So once we've obtained y, we just want to obtain the solution for x as well. Well, in this case here now, all we need to simply do is take this value of y here, which equals 5, and substitute it into either equation 1 here or equation 2. Again, it doesn't matter which equation you choose here, as long as you perform the algebra correctly and the calculations correctly, you will get the correct solution for x as well. Here, I'm going to substitute this into equation 2 here, this 2x plus 3y equals 21, again, just because it's, makes it a little bit easier. So in that case, substituting y equals 5 into here, we obtain 2x plus 3 lots of 5 is equal to 21. Well, 3 times 5 gives us 15 here. We obtain 2x plus 15 is equal to 21. And then subtracting 15 off both sides, we obtain 2x is equal to 6. And in that case, dividing by the coefficient of x here, we obtain x is equal to 3. So our solution in this case then is x equals 3 and y equals 5 there. Which gives us the solution there to our example using elimination. Moving on to method 2 now for solving simultaneous equations, we're going to use the method of substitution here. And we use substitution here because we have a non-linear equation. Notice this x squared plus 2y equals 31. Because we have this x squared here, this is a non-linear equation. So in that case, we use substitution to solve this simultaneous equation. And what we need to do here is rearrange our second equation for either x or y. And again, it doesn't matter which of these we rearrange for. However, we always want to make this as simple as possible. So in this case, I'm going to rearrange here for y. So y equals 14 minus x there. Okay, and all we're simply going to do then is substitute this into equation 1. So therefore, substituting this into equation 1, we obtain x squared plus 2 lots of this y value here, which is 14 minus x. So 14 minus x, and this is equal to 31. Now here, we're clearly just going to start by expanding this bracket. So we obtain x squared plus 28 minus 2x is equal to 31. And here now, if we get this in the form of a quadratic which we can solve by setting equal to 0, what we're going to obtain here is x squared minus 2x. And we have 28 here, and we need to minus 31 off both sides, and then in that case we obtain minus 3, which is equal to 0. Now here, the first thing we should always check is whether we can factorise this quadratic. We may not always be able to factorise a quadratic, and in that case we would need to use the quadratic formula or by completing the square. However, this is a nice example which does factorise. And in that case, when we factorise this expression, what we obtain here is x minus 3 times by x plus 1. And this is equal to 0. And what this tells us is that we obtain two solutions. So therefore, x is equal to minus 1 here. Setting x plus 1 equal to 0 would mean x is minus 1. We also obtain x equals 3 there. Setting x minus 3 equals to 0, we obtain x equals 3. Now again, we also need the corresponding y values here. So when x is equal to minus 1 here, x is equal to minus 1, and again, you could substitute this into either equation here. However, it makes sense to use our rearranged form here for y equals 14 minus x. Simply substituting our x values into this equation here, we obtain our y value. So y is simply 14 minus 1 here, which gives us 15 when x is minus 1. And then repeating this now when x is 3. So when x is 3, what we obtain here is y equals, again, 14 minus our x value, which is 3. So 14 minus 3, giving us 11 there. So in that case, if we write our solutions, so our solutions here are simply x equals 3 and y equals 11. And we also have x equals minus 1 and the corresponding y value of 15. And that gives us our solution there to this simultaneous equation using the method of substitution. And finally, we also need to be able to interpret simultaneous equations geometrically. So what do we mean by interpreting simultaneous equations geometrically? Well, for example, if we obtain two solutions once we've solved our simultaneous equation here, what that means is that the graphs intersect twice here. Okay, and like you can see, it intersects at this point here, and it intersects at this point here. So for example, one of the x and y values would correspond to, say, this point here, and the other x, y value would correspond to that point there. So that's what those solutions actually tell us. They tell us where the graphs intersect. If we have one solution, that means the graphs meet at a single point. And what that would also tell you is the straight line is a tangent to the curve at this point. Okay, so if they meet at this point here, what that means is that the straight line is a tangent to the curve at this point here. Let's say x, y. Okay, so that's what we'd be able to deduce there. And finally, if we have no solutions, what that tells us is that the graphs do not intersect. Clearly, if they don't intersect, then we wouldn't obtain a solution there for the two curves or equations in that case. So that concludes this Maths Made Easy video on simultaneous equations.